It's Saturday, September the 19th, and we're in the wing shop. Ron's taking the clamps off the lower spar cap.
I'd be whistling with some of that.
The rear spar has been made, and it's waiting the outside covering to complete the spar. It's been varnished inside. Maple blocks are all in place. There, the crane. Table jig is prepared. All the angle frames are installed along the outside line of the new spar cap, and wax paper has been put to prevent the glue from sticking to the table. The two-part epoxy glue is carefully proportioned out. On each big gluing day, we prepare test samples to be broken to check the glue joints. 1/2 by 1/2 by 4-inch long sticks are glued to each other with a 1-inch long stick in between. And those are the break samples. One for us to use and one for DOT to use. 50-foot long spruce laminations, which have previously been scarfed, are now fitted up loose and dry to ensure that scarf locations don't coincide. In each 50-foot lamination, there's approximately 2 20-foot pieces of wood and a 10-foot piece, and all the scarf locations have to be staggered according to the book. Laminations are laid out of the way in preparation for gluing. They're very fragile and skinny at this point. They can easily bend, and then 50-foot ends have to be picked up by 2 people. It's poured out in a line along the board laid flat, and the glue is spread out with a paint roller. Laid out glue is closely inspected to make sure the whole board is wet. All the while this is going on, the original 58-year-old wing of AAM, which was found in the Yukon bush in the summer of 1985, hangs on the wall of the shop as a constant source of information on laminations and ply thicknesses. This was used throughout the project in addition to the drawings which came from the old Fokker files. The scarf patterns have now become unglued, but they're still good evidence of how the wing was constructed. Completion of the gluing of all the plies, then the clamping operation starts. 7 plies of 1/2-inch thick wood are clamped in place with approximately 100 clamps. And finally, all the clamps are in place and tightened. The glue joints down the wing are then set. This entire gluing operation takes some 3 to 4 hours.
After the spars are removed from the form, the electric cleaner is used to clean the epoxy overrun off the edges. Sideways stuff to take. At this point, we're leaving it a 1/16 of an inch wide to allow for trimming. After the spars have been tapered in both directions, they're then placed in the jig and clamped to the outside forms. Comes the lengthy chore of gluing the verticals in place between the caps. The most time-consuming ones are the diagonals. After these rib stations are installed, we have to plane the spar caps down to the correct width and level them up with this surface, which we do first of all with a rough cut. And as we get closer, then we start using large plane, making sure the surface of the wood is dead flat so we can apply the plywood to it. Each piece is prepared with a scarf joint at each end with a specified plywood lap plate on the underside. Then nailed in place with brass nails. This inboard panel is 1/4 inch plywood. It's held in place with 1-inch nails. The plywood steps down in thickness out to the outboard tips, which are 1/16 inch plywood. After the webbing is all installed and the glue is well dry, cured, we remove the steel angles that form the jig. Fokker wing spar, 200 pounds of it. We're moving the spars over to the fuselage shop to make sure that the wing fits the fuselage. Yeah.
Oh my God.
June 4th, with the help of neighbors, fathers and wife,
Sure.
we're putting the spars in the fuselage to fit the wing to the fuselage. This is the rear spar, the lighter one. It's only 140 pounds.
I'm fine.
The front one took 4 of us to lift. It was 200 pounds. We drilled holes to fit all the wing spars.
trial fit of components, June 11th.
Well, like I say, just standing, flying there, bouncing all over the place.
After all the spar fittings were set up on the fuselage jig, then they were again loaded on the trailer and trucked back to the shop in town, where they were set on the trestle upside down in the shop, leveled using a survey level, and the process of installing ribs was begun. Of course, the wing tapers in plan and in thickness, and it has some twist called wash in or wash out as well. So only one rib on each side is the same. They're made and fit in pairs. There's a string line using a wire that's been set from one end of the wing to the other to ensure that there's no kink in the spars. And another string line will be set up between the root ribs and the tip rib out here to ensure that the trailing edge is straight. This is the shape for the center ribs. It's been traced on tracing paper, and we'll use this to obtain the airfoil shape for the center ribs over on the wing. This time we're going to do station 9. It's tapered down from the root rib at station 1. Is this outline? Now, in order to get a nice smooth line, we're going to use a little piece of cap strip as a spline. Using knees, fingers. And whatever we have, we get the best curve through these points. The second one, of course, is easy. Just trace the first. Next step is routing and cutting the holes in the rib to suit this drawing here, which we got from the FAA archives. The center line of holes, stringers, stiffeners. Takes about an hour a rib to do these. The holes for the stringers are made in a homemade hole punch. There's about 400 holes in all the ribs. It seemed like it was easier to make a machine to do this than to do them all with a drill and a file. The various size lightning holes are traced out with plywood, prepared for routing. Now you drop the router in. Having a bypassing U router jig like this allows us to change the size of the holes with the varying tapers of the wing. The
jig is clamped on to keep it from moving under the router. This to take about 10 pounds of wood off of 40 ribs. Layout on the second rib is much easier than the first. It's just simply traced from the first. At this point, the cap strips are glued onto the ply ribs. The cap strips are aligned with one gluey finger while the other glue covered finger holds the hammer. The top camber is a little more difficult because of the curve. We do the same thing starting out at the tail end of the rib. When it's all done, the nails are at about a 2-inch spacing along the caps. So there's probably about 70 nails in a rib. These cut and fit, two pieces exactly alike. Make sure it fits. Nail it with extra long nails, or 1/2-inch nails. The nails will go through and mark the center position. Of the stiffener on this side. So when we turn it over, we have 2 nails to mark the position. So we simply mark an offset on the nail. It would be visible as we put this one in place. Fairly tight-fitting stiffener on this side. Then we nail both of them by running nails through on this side. Of the loose rib pieces that we have to install, probably the hardest ones to do are the tail ribs. They have to be fitted up to the rear spar, and they have to precisely align with the string line which we've drawn from the taper rib to the maximum size root rib. And fitting these things, even though we make them precisely to the contour of the factory drawings, they never come right on this string line. Once that side is on, this is rib station 10. That will fit in there like that. The process of installing stringers between the ribs means putting these 1/4 by 7/16 square spruce stringers, sliding it through the holes that we've previously punched in the ribs, sanding it to adjust the hole location sometimes if it's not quite on. And then at each rib location, making sure that the rib is straight fore and aft, marking where they should be slotted. Again, these stringers in 8-foot lengths are taking about 45 minutes each to fit and prepare and fully glue into place. But of course, one of the difficulties in putting the stringers in the center of the wing is access. You have to climb over and crawl under things. With the rib pitch of 16 1/8 inches, it helps not to have breakfast before you start working here.
And so the wing is starting to take shape. The nose ribs, each represents about 3 hours of work. Laminating the caps, gluing the caps to the rib, steaming the caps, getting all the tight curves that are required. They're real easy to put on though.
The wing nose ribs look very much like the rest of the ribs on the airplane, except the very tight curvature at the nose means that the cap strips have to be laminated. We start out with a nose rib at station 1 with a curvature like that. We end up at station 16 at the wingtip with a very tight curvature like that. Each one of these plywood ribs is to have a 1/4 by 1/4 cap strip nailed to each side. And as you can see from the mess of ribs that are built right now that aren't on the wing yet, each one of these cap strips is laminated from 2 pieces of ash. Now, the way of doing that, of course, is to steam the ash until for an hour and a half until it's very pliable, and then bend the pieces of ash in a form and hold them in a form until they're tight, or until they're dry and bent in a tight curve. Following that, they're laminated up in this rib jig, and you might be able to see from the jig, it's an adjustable jig with jig pins that drop in at each rib station. The small rib station follows this line here, and the number 1, the large rib station, follows the outside line. This is one of those cases where the smaller the rib, the harder it is to make. These ribs are laminated, these cap strips are laminated, of course by steaming them. We've made a tall, narrow cauldron that takes a couple of quarts of water. These pieces of ash get quite pliable. December the 3rd, 1990, we have the wing frame sitting in the shop, getting set up for the skinning operation. The aileron's an oddball sort of thing. It's cut out of the wing after the wing is skinned. And so it means putting all the corner blocks and all the framing for the ailerons such that when the aileron is cut out, that all the corner blocks will be installed in the right place. Leading edge at the center of the wing for the cockpit enclosure. There was some difficulty in this because it's a rather complex shape. It has to fit fairly tightly around the
cockpit enclosure. The end ribs are sloped. And they all have to be ferried into to this scalloped end to provide better visibility for the pilot. Forming the plywood to fit the leading edge, and we've wrapped some aluminum over the D nose here, and we're steaming and bending plywood to fit over this and allowing it to dry in place using these little cinch straps to hold it in place. It can be much easier done now before the covering is on and we can't use these cinch straps. This is the neat little device that Ernie Favreau, former Starrett mechanic, told me about. This is a wheel that looks like a pizza cutter. It's an aluminum disc with pointed little nails situated 3/4 of an inch on center. And it's used to put pinpricks in the covering material to ensure that we get nail spacings exactly correct and neat and tidy looking. You can see that sample plywood there with 2 nails sitting in it. The nails have just been placed in little pinprick holes. Works very well. Have to make 2 others for 2 different nail pitches on the wing. The top of this spar is now capped with what we call an apron plate. It's a 1/16 plywood plate that's fully bedded and glued to the top of the spar, and it brings the spar profile out so that it's flush to the surface of the wing rib. The plywood joints are butt jointed over this lap reinforcement plate, such that we have a full strength glue joint in the plywood. And if we look at it from the underside, if we can see it, we can see that the plywood has been scarfed on the edge to provide about a 3/8 inch scarf taper transition to the covering material. Doing it. This is the sequence of forming and steaming the leading edge sheets in preparation to nail them on the airplane. This is the first sheet nailed on here, 6 hours of work the other night. And I put a cardboard template mark the template. And as I work down the wing, this template gets smaller. And cut the template to shape for this smaller taper. That will be the template for cutting the plywood. Next, take the same sheet and set it on the plywood. The face grain on the plywood has to be in the same direction as indicated on the factory drawings. Okay, we cut the sheet of plywood. It cuts real well with this carbide blade poked through a tight wood hole here. Next, the sheet of plywood goes into the stainless steel tank for steaming and bending. The tank wasn't made big enough for a full sheet. It works for the part of the sheet that needs the tightest radius bend. The actual wing itself is used as a form to form these leading edge sheets by placing an aluminum sheet over the nose ribs. This one has been bent to fit the various smaller ribs as we work down the wing. They're held here under some pressure. It will be perfect for holding the ribs clear and free of the wet to be formed over this. Okay? With the aid of these straps, this plywood has been pulled to a tight curved shape. We'll just give it one last application of steam. And let's see if we can fit it to the wing. Stringers are another fun thing. They're pieces of spruce, 1/4 inch by 7/16 of an inch. They have to be fitted in the lines, in the holes that have been punched in each rib. And hopefully they're in a straight line. For the full extent of this piece of stringer, we eyeball down the line to see if it's straight. This one is sufficiently straight, which is very fortunate. Then we mark with a pencil the position of the rib. Because the stringer has to be notched to bring it out flush to the surface of the skin of the wing. The position of each rib that's been marked is then cut and tacked on. After this stringer is fitted, then it has to be backed up with a little reinforcing block. These are cut out of the same material, 7/16 by 1/4, and they're simply glued on the back. They're a taper block glued on the back to hold the stringer flush to the back of the sheet line. Occasionally when it's a little bit loose, I'll end up putting a little scrap of the wedge in behind it, gluing that in place, and then cutting the rest, the excess off later. And that's the sequence of putting the stringers in place. No nailing required. The next repetitive ordeal is that of putting the apron plates on the spars. That is the plates that provide the lap plate underneath the skins of the plywood. The lap joint is made over the spars. Each of these apron plates is cut out of 1/16 plywood scraps, and it's fitted with a scarf joint on the underside in order to provide a little bit of a taper transition to the underside of the plywood. This one has already been glued and just tacked in place. It's just a question. This is the easy side. The underside, nailing overhead, is a tough one. By far the most difficult sheet to place on the wing is the nose sheet. Here's one now in place. This is actually the most difficult of all because it's the top sheet where you don't have access in through the ends. It's placed over the adjacent sheets, lapped over it, and it has to be put on first because the other sheets have to butt up to it. The second sheet that goes between the front spar and rear spar is ready to place now. The most difficult part of nailing it is the underside, which means setting the nails first in the board and then nailing it upside down. The problem is you don't hit so well upside down, and I bend lots of nails. So to prepare the bays to lay on a flat sheet, you first cut the sheet to size. You get all the nail spacings located on it. All the center lines of stringers. Then lay the glue on the stringers, lay the glue on all the mating surfaces, and pull the sheet into place.
One of the difficulties with a big wing is getting access to the middle of it when you're tacking it.
Oh, yeah, doesn't that get boring after a while to do all that?
Yeah, just after about 5 minutes it does.
Yeah, yeah.
Okay, we're going to use the pizza cutter here to mark the nail spacings. We have a stringer right under this line. And because the stringer is only 1/4 of an inch wide, you have to fairly precisely mark it. Nail holes 3/4 of an inch apart. On these stringers, I'm just putting a nail in every other hole according to the drawing, about 1.5 inches apart. This is probably the most miserable part of putting on these plywood skins, is doing the leading edge sheet where 1/2 of it has to be done upside down. Once they start bending, they hardly ever get them in. God damn. So as you can see, 20 minutes later, after hammering this row of 90 nails, I've bent 22 of them, and we'll have to pull them out and set in new nails. That's about a 25% flub ratio.